Find the domain and range of this function. The domain is every x value from here to here. So domain would be x equals, what's that bottom end? What's the low end going to be? Well, that's the bottom y value, but I'm looking for the x values. The domain is the x values, and the lowest x value is -1. Is -1 included in the graph? Yes, how do I know? It's a filled in circle, so -1 is included. What is the high end on the x? All the way up to 5. Okay, does 5 count? No, because it's an open circle. My range is a list of all y values, so from here to here. What's the bottom end on my y values? -5. Does -5 count? Well, let's look. Here's the line. Does that line hit the graph? Well, it misses on the right side, but it hits on the left side. So it does include -5, so we put a bracket. What's the highest number? 2. Does it hit 2? It does hit 2. How do we know? If it doesn't tell us whether it hits or not, it always hits. So in order to miss, there would have to be a circle, an open circle. So 2 inclusive. Okay. Oh boy. Just want to get rid of, there we go. Okay. What are the x-intercepts? Where does the graph touch the x-axis? 0 and 4. Good. Where does it touch the y-axis? At 0. Now, what part of the graph is above the x-axis? What part of the graph is positive? What would be this part of the graph? So if we look at the x values, every x value from here to here, so all of this stuff is positive because it's above the x-axis. So the interval of x values that give me positive numbers would be, what's the smallest value that gives me a positive number? 0. Does 0 actually count? No, because 0 is on the x-axis. And if you're on the x-axis, you're neither positive nor negative. So it's from 0 all the way up to 4. And we don't include 0 and we don't include 4. Okay? All right. Negative intervals. Negative intervals are going to be outside of this mark. So this portion of the graph here is negative. It's below the x-axis. And this portion of the graph is negative because it's below the x-axis. So the negative portions are actually two separate intervals. So we're going to have two answers for the negative version. How do we describe this graph on the left? What's the lowest x value in that piece? -2 misses, but -1 hits. So the negative intervals are x equals -1. Do we include -1? Does that line on -1 hit the graph? Yeah, it's a filled in dot. And how high do we go before we run out of negatives? My graph is getting hard to see, so let me erase some of this. So here's the piece that's negative right here. So it's everything from -1 to 0. Do we include 0? No, because 0 is on the x-axis, and we never include the x-axis. Okay? Now we're going to look at this piece over on the right. It's negative from here to here. Just that little piece. So what is the smallest x value in that group? It'll be 4. Do we include 4? Nope, because it's on the x-axis, and we never include a number on the x-axis. And do we include 5? No, because it's an open circle. So there we go. Today, we're going to go one step further, and instead of looking at positive intervals and negative intervals, we're going to look at increasing intervals and decreasing intervals. Okay? So let me show you what that's like. Let's imagine that I was traveling from the left side of my graph to the right side of my graph. So here's my car. Okay? As I travel this way and I run into the graph and I travel along the graph, well, and I disappear out here. What portions of the graph make my car go up, and what portions of the graph make my car go down? And you're always traveling from left to right, just like you read a book. You always start on the left, so, unless you're in China. So as I hit the graph, during some of that travel, I'm going to be going up, and some of that travel, I'm going to be going down, and part of that travel, I'm going to be going neither up or down. So what part of the graph has me going up? Where do I start going up? From -1. When do I stop going up? At 2. What happens at 2? I'm going flat. So if I were traveling along this line, I'm going up, 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 up. But when I hit the top, for that one little instant, I'm actually going straight. And then all of a sudden, I start going back down. Okay? So, oops, put that back. So between those two lines, I'm traveling up. And then between this line and this line, I'm actually traveling down. So I'm not looking, is the graph above the x-axis or is the graph below the x-axis? All I'm looking for is my car going up or is my car going down? Am I climbing the mountain or am I descending the mountain? Okay? So I'm going up, 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 and then I start going down. So this interval here describes me going up. So I could say that I'm increasing from x equals -1, inclusive, all the way until x equals 2. And we decided that at 2, the car is not moving up or down, it's going straight. So that one does not get counted in the increasing interval. After that, my decreasing interval is x equals 2 to 5. So I'm going up until I hit 2, and then I'm going down until I hit 5. And that's what we're going to do today. If you don't already have this worksheet, you need one. So let's look at number 1 on your worksheet. Let's graph the function 4x minus 6. So my graph looks something like this. Let's bring back my car. Here's my little car. As I travel along that line, when am I going up and when am I going down? I'm always increasing. I'm always going up. Never going down. So you could say the increasing interval is all real numbers. You could say it's negative infinity to infinity, or you could say it's everywhere. I would accept any of those answers. When is it decreasing? Never. Now, leaving it blank would be wrong. You need to state decreasing never, because it never is decreasing. Okay? Let's look at the next graph. Okay. So the next one is x to the third. So this graph looks like that. Pull my car down. So let's follow the car as I travel along this graph. When is it increasing? Yeah. Is it ever not increasing? Let's watch that again. It does flatten out right here. And for one little instant, I'm going flat. Everywhere else, though, the car is going up. So you could say the increasing interval is from negative infinity to 0, and then from 0 to infinity. What is my decreasing interval? It never decreases, so I can say it's the empty set. It's the set of numbers that has no numbers in it. That's what that symbol means. Okay. Is there another way to, yeah, you could write never decreases. Is there another way to describe the increase? Can we include everything except one number? Have I shown you how to do that? You could say x equals the real numbers, but x does not equal 0. So that would include every x value except 0. Okay. Let's look at the next graph. X squared minus 4x plus 5. Does this one have increase and decrease? It does. So looks something like that. So if I were to travel on this graph, I were to drive down that mountain, and then I'd hit the bottom, and then I'd start driving up. So we're going to break this into two parts. The part on the left is a decrease, and the part on the right is an increase. Can we trust that middle line? Where does it look like we change directions? At 2. Can we trust it? Sometimes we can, sometimes we can't. If it's a parabola, if it's this U-shaped graph, you can. But if it looks like this, let's say this one is 1 and this one is 2, then this one will not be 1.5. It'll actually lean more to the left. It'll be 1.4 something. So we can trust this one, but some of the others we won't be able to. What is my interval of increase? On number 3, yeah. Not 3, 2. It's going up from 2 to infinity, because it hits the bottom of that canyon at 2. So from 2 to infinity, it's increasing. When is it decreasing? Negative infinity to 2. So the left portion is going down and the right portion is going up. Okay. Okay. Let's look at number 4. So let's graph this. Negative x squared minus 10x minus 25. Oh boy. Negative x squared minus 10x minus 25. So our graph looks like this. So if I drive my car along this, go up the mountain, I hit the top, then I go down the mountain. So this left side is up and the right side is down. What x value makes me turn the corner, change directions? At negative 5. So my increasing interval is from negative infinity to negative 5. My decreasing interval will be from negative 5 to infinity. Okay? All right. Okay, this next one's going to trick us a little bit. X squared minus 5x minus 1. When does this graph switch directions? We don't care about the y value, right? We're just looking at the x value. We want to know what describes this piece of the x-axis and what describes this piece of the x-axis. Okay? So we need to know, when does that bottom of the graph occur? We could guess. What would you guess would be this line right here? It looks close to 2.5. Can we trust that? No, we need to use a calculator to find that. So everybody push second, and then calculate. Which one of those do you think will find the answer for us? 0 will find where it hits the x-axis. Intersect will find where 2 graphs touch, so that's not it. We want to find the minimum. So click on minimum, and then you're going to do that same left bound, right bound guess that we've done in the past. We think the answer is at 2.5. So my left bound, I can say my left bound is somewhere over here, maybe at 1. And my right bound is somewhere over here, maybe at 4. And then my guess, I'm going to guess 2. And it says my minimum is 2.49 comma negative 7.25. Did anybody get one that says exactly 2.5? Yeah, my calculator's trying to be really smart. And it did 2.499999999. That's because my range was a little bit too big. If I were to do the same thing, so I picked 0 and 4. If I pinch that in a little bit, I'll get a more accurate number. So if I do second calc minimum, and I do 2 and 3, and I guess 2.5, then it's exactly 2.5. So sometimes the calculator misses it just by a little tiny bit, but you can just round it up. So this is in fact 2.5. So my graph is going down until I hit 2.5, and then it's going up. What does this negative 7.25 tell me? That's how low the graph gets. If we don't care about how low the graph is today, on other days we might, but today all we care about is what x value gives me that direction change. So this would be, we're increasing from 2.5 all the way up to infinity. So from the bottom of that graph to the right, I'm increasing, and I'm decreasing from negative infinity to 2.5. Okay. Let's look at number 6. Graph of number 6 is negative 8 over x. Ooh, this one's kind of tricky. Where is this graph increasing? They're both increasing, right? So this piece on the left is always going up. What about the piece on the right? It's going up. Is it ever going to flatten out? No. Not until it reaches infinity, which will never happen. So it's always going to go up, but it's going to go up at a slower and slower and slower pace. Imagine a mountain that was infinitely long, and the closer you get to the top, the more level you go, but you'll never actually reach the top of the mountain because the mountain is infinitely long. Okay? So this left piece, when is that left piece increasing? From negative infinity until not infinity. There is a number that doesn't exist. It gets closer than negative 1. It gets closer and closer to 0. So this graph is going to, if that's my x-axis, it's going to get closer and closer, or y-axis. It's going to get closer and closer to my y-axis. So 0 doesn't count. What about the other side? Where is that right piece increasing? Now, where does that piece on the right begin? Starts at 0. It goes out to infinity. So really, it's increasing everywhere except it's not increasing at 0 because the graph doesn't exist at 0. So x equals all real numbers, but x is not allowed to be 0 because the graph does not exist at 0. So it can't be increasing when it doesn't exist. Right. Number 7. Oops. Okay. So if I draw this graph, and I run my car across the graph, starts over here at negative infinity. I'm going to follow that line down. When is this graph increasing? Never. When is the graph decreasing? Always. It's always decreasing. So that one would be all real numbers. All right, number 8. Okay. So the graph comes up, back down, and back up again. Okay. Now, don't trust the minimums and maximums here. You always want to test them if it's an x to the third graph. If it's an x squared graph, you can usually trust them if they look like they're close to a whole number. But on this graph, you can't. So I'm going to break the graph into I'm going to break it into 3 sections. So this section on the left, what's happening on the left side? The graph is going up. Okay? What's happening inside that middle section? The graph is going down, and on the right, it's going up again. So my increasing will have 2 intervals. My decreasing will have 1 interval. Now all I need to know is what are the x values of that maximum and this minimum. The funny thing about this is, does this point actually describe the maximum value of the graph? No, what is the maximum value of the graph? Infinity, because on the right side the graph goes up forever. Whenever that happens, we refer to that little hill as a relative max. So imagine you were climbing a mountain, and as you climb the mountain, you're going up and up and up, and you go over a hill and you start coming back down. You go up again. This little hill over here was not the top of the mountain. It's a relative max, meaning close to that point, that is the biggest number. But if you were to continue driving, eventually you're going to climb an even higher mountain. So we call that a relative maximum, but we can still find it using our maximum button. So second, calc, go down to maximum. And one thing we have to be careful with is when we set our left bound and right bound, make sure that you don't include some point up here. When I set my bounds, I want to make sure that my bounds are short enough that they don't include this other maximum on the other side. So I'm going to set my left bound as -2, my right bound as -1, and I'm going to put my guess as -1.5. And it says that my maximum is actually -1.53. So this point here is x equals -1.53. Now I need to find my relative minimum. So second calc minimum. And it looks like it's really close to 1. So my left bound I'll push 0. My right bound I'll push 1. Or sorry, I should have done 2. But that'll still work. And then 0.5 as my guess. And that x value is 0.86. Now remember, we don't care about the y values in this case. If we were trying to find the domain in the range, the y value could help us find the range, but when we're looking for increasing and decreasing intervals, all we care about is the x value. So now, we decided I have an up portion on the left, a down portion in the middle, and an up portion on the right. That piece that's farthest to the left, what is the interval of increase? Where does that increase begin? Negative infinity, comma, that piece on the right, or that piece that piece on the left ends at what value? Negative 1.53. So that takes care of the piece on the left. The piece on the right begins at 0.86 and it ends at infinity. And then my decrease would be from negative 1.5 until 0.86. Okay? All right, I'll give you the rest of the time to finish the rest of this worksheet. It is due when you come back.